Okay, so we'll welcome back again to the process control core shop webinar. Before we start, once again, I'll just revise what we have seen so far. We've seen that the core is important because of its criticality and surface finish requirements. It's the most neglected area in the foundry, as we all know. So process control, improving the process control is going to be help in improving the productivity, quality, and the commerciality of the core box section. So it is very important area which we are touching today. We started with the core box inspection. The core box inspection is another neglected area where we have to see the venting, then actual core box inspection cleaning we can say then vent cleaning, then avoid damages of the core box, then some preventive measures need to be taken care in the core box inspection we have seen. Then tool life has to be monitored, like our patterns core box tool life also need to be monitored. Proper storage of core box is required. Then we go to the three areas of core box core shop we can say is cold box, Novec and Shell. Cold box, as we all know, is the most popular or most volume given section in the core box. That is cold box. It has been very popularly used in the world. You can say here A part and B part and amine is used. Then we go to Novec, two-part Novec we have seen. Two-part Novec is a self-setting process of core making. And then we go to shell core, which is, we can say, hot process, where we have to heat the core and to get it rigid and or baking. We have seen some important factor in the shell core in particularly because some of the our clients of MHMC are using shell core, so I have taken more emphasis on this shell core also. The resin percentage is important. You can use 2.5 to 4.5% of resin depending on the strength what you require. As strength are increasing, resin percentage increases, gas evolution is also increasing. So you have to optimize your resin percentage. Very important thing. You just cannot go on increasing your resin percentage. You will land in a problem in the casting for the blowholes because your gas will be more and more gas generation. It will be difficult always to remove the gas from the mold or from the mold section when we are pouring. So it is important to use less is always better, so less resin percentage, optimize it properly. So this is important. And now we are going to see some of the survey reports which we at Dynamic Foundry Group has taken last month. Uh, so this is about the scratch hardness, how much scratch hardness normally we get, and the result we can say is most of the people, that is almost 67% are using getting scratch hardness between 60 to 70. So as I told you, the 60 should be always there. Below 60 do not operate. It will always better to go above 60. Second thing was AFS used for the cold box core making, and almost 83% of the foundrymen are using around 50 to 60 AFS sand. We are talking about the gas content also. When we are talking about resin, I told you that gas content has to be controlled. What are the gas content of various core boxes? The cold box is 9 cc to 11 cc. So cold box is having minimum gas. So always prefer to use cold box core whenever you have a choice, because it will give a low gas so that whatever gas is generated is easy to escape in your molding, so you don't have to take more efforts in removing your gas in the molding line. Novec will give 11 to 14, which is moderate one, but in shell it is around 40 to 25. So always remember, shell core will give you more gases. It will produce more gases in the during the burning of core, and then you have to have better gas removing or venting processes in your molding. So that is why I'm always saying that in shell core, try to optimize your resin percentage. More will be the resin, more will be the gas. So try to optimize your resin percentage. We go to the sand mixing. It is very important factor. I think this is another area I feel everybody is quite neglected, because we are focusing more on green sand mixing. We are talking about GCS permeability, AFS, then active clay, dead clay, everything. But in core shop sand mixing, we are not giving any importance to that. Even that mixer is been not checked many times for the preventive purpose. The blade gap has been not seen. All those things have been neglected. That is why I think this is very important factor to relook at your core shop with a new vision with after this particular webinar. The sand mixing is very important. Again, mixer maintenance plays an important role. Like always, any mixer need proper preventive maintenance. So in this case also, maintenance plays an important role to get homogeneously mixed sand. This is very important. If sand is not mixed homogeneously, what will happen? Like in cooking, we have an we can say making a chapati homogeneous that thing is required. If homogeneousness is not there, will not find the things are coming well. So homogeneity of the mixing of the sand is very important, and it will come only through a good quality of mixer and good preventive mixer. So it is very important. In mixer, blade and scraper gap has to be checked properly and it is to be maintained properly. It has to be around 2 to 3 mm normally. Do not take excess sand than mixer capacity. Clean mixer on daily basis. This is also important. So excess sand, people are having a mixer of 100 kg and they are putting around 150 kg to 100 kg sand inside it and try to mix up it. So it is not giving you a good result. You have to use your mixer to the optimum capacity, not to the excess capacity. This is very important. Uh, Clean mixer on daily basis. You have to just clean it properly from inside after every day, after every shift, so that mixer will remain good in a good condition. It will not give you a bad quality of sand. One more thing I am like to say here is use different mixers for no bake and cold box. Many times people are using same mixer for the no bake as well as cold box. So it will give you little we can say cold box material to the no bake and no bake material to the cold box. It will hamper your quality of sand to some extent. So try to avoid the mixing of those two processes in single mixer. Try to give different separate mixers. So it is very important again. So sand sticking to the mixer of inner wall is to be avoided. This is one of the Kaizen which we have done it in our foundry to control the mixing time, because mixing time is another important factor in the mixing process. First we have to add the sand, then we have to we can say mold it to some maybe one minute, then we have to add a part, then again we have to mix it, then we have to add b part, then again we have to mix it and then take out the whole mixture. So this is what the cycle. You have to follow this cycle, and for following this cycle 1 minute or 30 seconds or 45 seconds, normally people are seeing on their mobile or watch. So for to avoid this manual interference and manual mistakes, what we have done is we have set a PLC controlled individual system where you can say a red ball is there and red ball is there and blue ball is there, and then there's a hooter. When you put first a part, when you mix for the first minute, it will blow red ball. As red ball blows, you have to add a part. So the indication for the pupil is once red ball is on, he has to add a part. Then it will mix for another 1 minute. Then it will again glow for a blue bulb, and when a blue bulb will glow, you have to add B part. Once you add a B part, then it will another mix another 1 minute, and after that last 1 minute, it will give a hooter. Hooter means he has to take out all the mixture. तो नथिंग इज केप्ट ऑन मैन्युअली. तो ऐसा नहीं होगा कि आदमी ने आधा आधा मिनट ही घुमा दिया, उसके बाद ये पार्ट डाल दिया, उसको जल्दबाजी है इसलिए उसने आधे आधे टाइम में ही मिक्सिंग कर दिया. तो ये जो मैनुअल मिस्टेक्स है उसको अवॉइड करने के लिए यू कैन डू दिस काइंड ऑफ पीएलसी थिंग ऑफ पीएलसी ऑटोमेशन. So that is why I have shown it here for your ready reference. You can do like this. So this is a simple activity we can do. The important thing after sand mixing is bench life of a sand. every sand has a bench life. It is around 10 minutes for you can say cold box as well as for the no bake. So within 10 minutes you have to consume whatever sand you have mixed up. So you have to mix up that much sand only which you can consume in 10 minutes. For example, you are making a core of 1 kg and your cycle time is 2 minutes. So 2 minutes means you can make only 5 cores. So maximum 10 kg you have to mix और 15 kg you have to mix. अगर आप 1 मिनट में एक कोर निकालते हो और कोर का वजन 2 किलो है तो यू कैन गो फॉर 20 kg. सो सिमिलरली लेकिन आप अगर 100 kg मिक्स करके रखोगे और उसको 1 घंटा 1.5 घंटा लगा कंटिन्यूसली कोर बनाते रहोगे तो आफ्टर 15 मिनट्स और आफ्टर 20 मिनट्स the whatever the quality of core will be there, it will be deteriorated. You will not get proper scratch hardness, the strength of the core will be less, the surface finish will not be good. So try to use sand within your given limit and mix only that much quantity of sand in the mixer which you can consume within that particular minute. You can say 10 minutes or 15 minutes. It depends. Normally the standard is 10 minutes. People are using 20 minutes or 30 minutes also to some extent, but not more than 30 minutes, because some people where the core size is less or weight is less, they are using up to 30 minutes, but not more than 30 minutes is at all permitted. Even 30 minutes is too long, but people are using practically. What I am saying is practically people are using for 30 minutes, though I have written here 10 minutes, people are using for the 30 minutes, but about 30 minutes anything you produce will be having a bad quality. Try to use it within your own, you can make your own bench, you can benchmarking that I have made the sand and I have used it for 10 minutes. What is the scratch hardness? I use it for 20 minutes. What is the scratch hardness? I make it for 30 minutes. What is the scratch hardness? And you decide your own bench life based on your own mixing cycle, mixing, you can mixing capacity, mixing the mixer infrastructure, your core size, your core box size, your core machine, everything. So the every because everywhere infrastructure is different. So whenever you make your own benchmarking, it will guide you up to what limit I can go, and decide your own limit and try to follow with it. Do not over limit it. So this is another area which is important. Few more survey reports which I am sharing with you. That is A part binder. What we are talking earlier about is most of the foundries are using 0.8 to 1%. So this is a good thing that people are quite good in this area, that they are using optimum level of A part and B part. So I think this is a good feedback that we got during our survey. That percentage amine use is 0.2 to 0.3 is also very good. That 61% of people are using 0.2 to 0.3 amine only. So it's very good thing. Then how much reclaimed sand can do you use? This is one of the important area in core box, that you have to use reclaimed sand. But unfortunately, whatever survey shows, more than 76% people are using less than 25%. Even 44% people say they are not using any reclaimed sand. They are using only natural resources sand right now. So I think this is area where we as a Indian, we as a foundryman, we have to focus more on that. That how we can use more of the reclaimed sand to avoid the fast deterioration of natural resources. So this is area I think we have to focus. Then average core rejection, that was another area where people are been so much optimistic. The most of the people, that 1 to 3% of 55% of people saying that their rejections are within 1 to 3%. That is the waste sand during the core process is below 1%. So it is almost, we can say 4% is the total rejection plus wastages. One more important point which touching to is core storage. Next thing which is important is core storage. Once you make a good quality of core, it is very important to store it properly. If you not store it properly, what will happen? It will get damaged, it will get deteriorated, its quality will get deteriorated, and when you use it actually in the molding box, the core quality will get not as per our requirement. So whatever efforts we have taken in producing the core is all wasted because of improper storage of your core. So core storage is very important. One more thing is important is first in first out. Many times there are series of core production, and yesterday's core kept aside, and today's core we are producing taking for the molding. So it is also not preferred. So you have to use a similar process which we use in the stores, that first in first out, that is the PIPO method. And for that you can put board like this so that you can understand on what date the cores are been produced and when you have to use those cores. So identification is there, storage is proper, you can get the traceability of cores. So this kind of small things will help you to improve your cold box quality, core quality and casting quality. And it also gives you a good culture in the core shop as well as in the foundry. So this culture will help the people to get more productivity, more you can say benefit to the reducing their efforts and their fatigue. This is how people are most of the time using core transportation either through trolleys or plastic bins. This is the most popular method people are using for core handling or core transport. There are two questions around that core storage and core transport. One area was how much is the bench life of cores? After making the course, after how many days or how many time you are using it? So the answer which comes is 1 week to 1 month. So after making core, you have to utilize it before 1 month, not more than 1 month. So you have to keep it maximum 1 month. So I think around 11% of people are saying within 1 day, which is most preferred or most welcome thing. But many times it is not happened in most of the foundries. But 1 week to 1 month is better. If you go above that, definitely your core quality will be getting deteriorated. Then one more question was there, the core breakage rejections during the handling and the transport. And most of the people are saying that below 1% is 39% and 1 to 3% is 39%. So you can see the lot of differences there. Below 1% is very good, definitely 39%, and 1 to 3%, I think they have a lot of scope to improve. That is also 39%, and 3 to 5% is around 22% people. So there is a huge scope for this 39% and 22%, and I think this is an common scenario I'm seeing in all the foundries, because we when we make the foundries, we are not thinking much about core making, the core transportation, core storage, core handling, all these things. We talk more about the melting furnace, we talk more about the sand plant, we more talk about the molding lines and the infrastructure which we make, or layout which of the foundry which we design according to these important factors. And during doing that, we give neglection to the core shop and core handling and core storage areas. So that is why this kind of we can say drawbacks are there, or loopholes are already there, and now we have to overcome these all drawbacks and loopholes by proper planning and proper thought process, we can say, during our daily working. So this is area where the challenging area, we can say, challenging thought is there. We have to reduce this kind of wastages to give better commercial aspect to our foundry. Next part is the core painting. So after core making and core storage, we have to go for core painting. So core painting is another area. We can use either brush dipping type or brush type. You can see both the process been demonstrated here. To my right is by brush, and my left is dipping process. So both processes are being shown here. So there are two basic process, and two types of core painting are normally used. One is alcohol based paint and second is water based paint. So what is alcohol based paint? Is basically a paint which requires ignition. So after you brush it or apply the paint, you have to ignite the core for proper burning of alcohol, and this particular core practice or core paint practice is very important with respect to your safety also, because as it is getting burned immediately, the paint is getting burned immediately. You have to take care while painting. You have to take care that no paint is been wasted on the ground, or it is not kept near the hazardous material. It is not kept near the fire. All these things we have to take care. So safety precautions are need to be important. Alcohol-based paint requires just ignition, so you did not need a core oven. So there is another important thing, that you can run or you can use this paint without any additional infrastructure or additional investment. So that this is why this alcohol-based paint is most popular paint, because of less investment is required. Second is water-based paint. It is most popular because of its uniformity and the consistency of baking. So whatever paint you apply, you need to pass those core through the oven to dry this water-based paint. The cycle time is around 1.5 to 2 hours at 140 to 160 degree. Again, depending on your core weight, core size, the distance of your core oven, it is continuous type of oven or it is one time, yeah, we can say table cupboard type of oven. That depends on all these things. So this is general cycle time I have given. It depends on all many factors, other factors as well. But I think water based paint is good if you have a core oven. You definitely need a core oven for the water based paint for proper drying of cores. There are different ways of core painting, as telling you: brush painting, dip painting, and spray painting. Most popular is dip painting. Brush painting is applied also in some of the cases. One more area, one more you can say paint process is there is a spillover, that is the core is kept and above that core the paint has been poured. So that is another process which is been used in bigger company than to use a bigger core where the handling of core is difficult. This kind of painting process is being used. For the brush type, the viscosity maintained should be 10 to 12 second. Dip type, it should be 12 to 14 second. For the spray type, it is for 12 to 14 second again. So maintaining the viscosity is important, just like our primer which applied to the casting also. We need to maintain the viscosity of paint. Here also viscosity of paint has to be maintained, and for that we have to stir the paint thoroughly before we take it for the painting. So it is very important to thoroughly uh, we can thoroughly spray the paint, and then uniformity of the paint is measured with the before cup through viscosity, and then we can take it for the painting process. So this is very important factor. For that also we have a couple of questions during our survey. How many percentage of core do you paint? And the answer was 100% was the answer by 46% of people. 75% core are been painted by 35% of the people. So most of the people are painting the cores. Very few people are using it without painting. If you use without painting core, there is a chances that surface finish is not that good. You will not get that much good surface finish. There are chances that some metal penetration because of not using of paint. So I recommend to go for the painting wherever you can go. And the next question, do you have a core oven? 67% people say yes, they have a core oven, and 33% people say no, they don't have a core oven for the core baking. Next one was which method they are using for core painting. 89% people are saying yes, they are using dip painting. The next question was which paint do you use for core painting, and the answer was alcohol based paint and water based paint 50-50. So both are popular. It depends on whether you have a core oven or not. If you even if you don't have a core oven, many people are using water based paint. They are drying it in the air. But I think it is not most preferred method. If you have to go for core with water based paint, you must have a core oven, otherwise you can go with alcohol base as well. This is type of gauges. Sometimes you need to have some kind of gauges. This is one of the core we are producing at our end. We are finding the destruction during the core making process. We have make such kind of gauges. So you have to go for some kind of gauges if you require in the process to avoid destruction of the core making. I have sharing some of the production reports as well. This report is for CodeBox, where you can see almost all the data is there in the code in this report. If you go and make this kind of report, definitely it will help you to understand your strength, your weaknesses, what is happening there in the core shop on daily basis. There's a core name, weight is there. You have to verify the weight also. We are talking more about the casting weight. We are not talking more about the core weight, but somehow we need to address core weights also, whether it is increasing, whether we can reduce that core weight to some extent so that we can have some cost saving. So weight, getting weight is important. Then quantity produced, rejection numbers, then the inspection part of it, dowel pins. You have to check daily that whether your dowel pins are okay or not, your parting line is proper or not, vents are properly cleaned or not, stripping time is maintained or not, scratch hardness, what is your scratch hardness, what is your paint viscosity. So all these are process parameter which you have to analyze, we have to observe, you have to get this data for each core so that you can understand if there is any issue, what was went wrong during that production, you can analyze. You can also able to see that all the process parameter have been followed or not. Then in the bottom line you can see the material consumption, then sand consumption, A part, B part consumption, amine consumption, paint and thinner consumption is also there. Then operator's name is there, waste sand is there, percentage waste sand is there. So all these parameters are important for us to understand what is happening on daily basis in your core shop. So this is a, simple format or simple format we are using at our foundry. I'm just sharing with you. Similarly for Novec, it is the same format, just changes some important thing which are the difference like A part, B part. There is no amine, so I have removed amine from here, and this is for the shell core as well. In the shell core, you can see there is a point, there is a compare with master core for baking. You have to keep one master core at your core shop, that is biscuit color core, for the comparison of the backing of the core. Every time you cannot cut the core, so you have to keep one master, and just by seeing comparing it with the master you can clear the core. The scratch hardness is important. I have not put up here the temperature because we are not using automated machines. We are using it manually. There is no facility to check the temperature, but you can add that if you have that facility available in your machine to control the temperature of your core box. So this is another area we can increase in this introduce in this format. Then resin coated sand use, LPG consumption is very important. I think this is one of the area where we have to focus in the core shop. If you are using LPG cylinder, it's very important that you ensure that it is 100% empty before you uh, give it back to the store. Many times what happens, some LPG is there inside the cylinder, and you give it as it is to the stores person give it back to the supplier with some LPG, and definitely you are paying for 10 kg of LPG and you're consuming only 8 kg, and 2 kg remaining in the cylinder is a wastage for you. So it is very important to take weight when you take the cylinder, and again take weight when you give it back to the stores, so that you will have to able to monitor the consumption, and you can ensure that all the LPG has been consumed properly. So this is very important. That is why I put up here LPG initial weight, LPG final weight, LPG consumption, and that will help you to guide the costing of resin coated sand or shell core making, because in that particular process the cost of gas is very important. Gas, it plays an important role, and it plays a big role in the costing, so you have to monitor that to the fine tune extent. So this is very important again. You can make core hollows as I am showing you here with the kind of you can say uh, small small kind of pieces. You can make the core hollows so that you can reduce some weight of the core. You can make a cost saving. You can also help it for the better transportation and you can say because weight is less, then you can easily transport it or you can easily handle it. The weight is more, it is difficult for handle. So it is very important to try to reduce core weight by making core hollow wherever possible. We come to the last slide of the presentation. The important points what we have seen in during all this presentation. One is core box inspection, dowels, dowel pins, paints cleaning, etc. So give emphasis more on core box inspection because input is important for better output. So always important to give more importance to the core box inspection. One more point I have not specially put in the presentation, but it was a part of a presentation through various slides that your incoming sand is also important. You have to inspect it before you use it. The clay content of sand is important. AFS number of the sand is important. Sieve distribution of your sand is important. So another, this is another incoming area, incoming material you have to verify before going for the production. Then sand weighing is important during the mixing because again you are mixing 1%, that is say your mixer is 50 kg, you are using 500 grams for 500 grams for 50 kg. So but you are not taking 50 kg, you are taking 60 kg, then your resin percentage will be less, or you are taking 40 kg, your resin percentage will be more. So importance is to weigh sand as well as weighment of additives. Weighment of additives is also very important because many times particularly resin uh, where we are taking the resins with the a container which gets deteriorated or we gets binded with the resin और बाद में उसमें एक 100 ग्राम की जगह 80 ग्राम ही बचता है क्योंकि it got deposition of the resin. So you have to clean it periodically. It is very important. The measurement is very important. The cleanliness of those thing is very important. So you have to give more focus on that. 1 minute, I will just hold for 1 minute. Sir. Okay, so additives weighing is very important. Then sand mixing time is important. As I show you, you can make some small automation in that as well. So bench life of prepared sand is very important. Core making process we have discussed in detail, that is core, cold box, shell and no bake. Scratch hardening is important, as I told you, about 60 is required. Paint viscosity and paint steering is important. Before you take paint for painting, you have to steer the paint properly so that uniformity will be maintained. In the paint, the we can say a solid content and the liquid part will get properly mixed up for the proper homogeneous paint. Then painting and ignite of alcohol-based paint, the safety factor you have to understand and consider. For water-based paint, you need a core oven. Next point was oven temperature and soaking time for the core oven is important for the water-based as I told you. And last but not least, the storage and handling of cores with first in, first out. This is very important again. So this is from my side. If you have any questions, you can go and ask. Any questions? Anybody? So this is from my side. Thank you very much for attending this webinar. I think there is lot to be understand in the course shop. This is only a primary thing, I think. I am also trying to learn more in the course shop because uh, very few webinars or seminars, or very few experts are there in the course shop we are finding. So there is a huge scope for improvement in the core shop, and we need to work independently on our own in our own core shop, because every core shop has its own dimensions, its own size, its own volumes, own processes, own practices. So one has to understand what exactly is going right, what exactly is going wrong, and why it is going wrong, and how to improve upon it. You have to make a lot of efforts to gather the data, analyze it, and understand what can be done with this data and how we can able to improve it. Just like I was talking, we have couple of webinars in our dynamic group, a panel discussion we can say, with experts last month, and after that I have started various activities also, taking scratch harness from day from 0 hours to 3 months. What will be the difference? I'm just going on doing this activity. So you can do these activities, understand your process, understand what better you can do in your core shop, how you can improve your process control, how you can improve your quality of core shop, how you can improve your awareness of the people and the knowledge of the people in your core shop, so that you can get better results in the future. So by wishing you all the best, anybody have question? So by wishing all the,
This is Sameer Kapoor.
yeah,
I want to ask you something, sir.
yes sir, definitely, yeah, go ahead sir.
We are into manufacturing bathroom fittings, and we are using shell cores
Yes,
for our castings.
yes,
As you know, our casting sizes are very small. The weight of the castings are very small. So is
yes,
the size of the core also.
yeah,
So the problem is the core is usually very fragile, and at the moment we are using a resin percentage which varies from 2.4, 2.5 to 4.5 as suggested by you.
yeah,
But the problem is because of lot of gas emissions, we have when we decrease the amount of resin, the fragility of the core, it increases and there is a lot of breakage, even to the tune of more than 20%.
yes.
So can you suggest some other method wherein we can increase the strength and wherein we can decrease the fragility, or by some other method wherein we can remove the gases by from the core so that there is no gas entrapment during casting procedure? What else could we do? Like if we decrease the resin, the fragility increases, the core, the composition of the core becomes poor and it breaks very often. So
Yeah.
can you suggest
You
anything
have
in that?
issue of breaking only, or you have issue of surface finish also?
Surface finish is not an issue, sir, because with the core we are creating internal sizes. Outer side it is an MS mold.
Okay.
Within the inside of the product, there is no importance of
Yeah.
surface finish because we
Correct.
have to machine the inside.
Yeah. Uh,
So every product has to be machined from inside wherever proper size or finish is required. So finish is not a problem, sir. What we need is minimum gas emissions to decrease our rejections.
yes. For minimum gas emission, you have to go for less resin. But as you rightly say, your core size is very small and it is thin core. I think what? How many mm it is? 10 mm, 15
Sir,
mm.
it is not of the same size all around.
Yeah.
Wherever
Less.
there's the seat which we use for water flow,
Yeah.
the size drop downs to 8 millimeter.
That is what is making the problem you, because at one side you
And
have to use less resin, on the other
yeah,
hand you have a thin section, so it is little
we,
difficult to match both the things together. Uh, but
I
I
will
have
I
seen
will
people
later on
using.
share some pictures with you.
Yeah, tell me sir.
What we do is we keep an MS wire also because on both the ends of 8 mm we have at times 40 mm size of the core or 20-30 mm long core on the other side, and the
Okay.
two sides are joined with the piece which is hardly 8 to 10 millimeters in diameter.
Oh,
So that becomes a very weak loose end of the core, and core usually breaks from there. And we use MS wire also.
you are using MS Word also for the you can
Yeah,
say
I'll send you some pictures, but we
proper
need some suggestions in that.
okay. You have tried with iron oxide sometime?
No, we have not, sir. I do not have any idea about using iron oxide for cores.
Because I have seen some people are using iron oxide to get better strength in the core. It gives a better strength in the core. You just try it because, but what I have to think whether it's iron oxide will hamper your metal properties because it will come in contact, that core will come in contact with the metal as well. So that I
Definitely.
think that
Yes.
that need to be understood. I will just check up with Anand Bamsar on that once again because
Okay, sir.
he's a bit better understanding with the metal. So I will just go through
I
that and
understand.
I also you can send me some photographs of the core.
Definitely, I will, sir.
I will go through. We have some really good expert in the core box and core design also. So we'll definitely try
Okay.
to analyze it in a better way because as I am telling, you are on both extreme ends, and from
Mm-hmm.
both extreme ends you have to get better results. So it is a little challenging thing, though. Definitely we'll try our best, sir. You send me some
Right, sir.
photographs.
Thank you.
I will go through that and
Thank
I will
you.
come back to you on personally on that. But I
Thanks,
think
thanks
iron
again. Thank
oxide
you.
can do something on that, hopefully.
Okay, I got it, sir.
But
I'll also search on it and I'll expect some feedback from your side
because
also. So
in
that I
our
get the picture.
iron casting we are using some iron oxide in the resin coated sand to get better quality of core.
But we are doing only brass castings
Yes, that is
as
why that
from
is why I have to
yeah.
check it because whether it has some effect on the metal as well. So that has to check before.
I understand. Thank you so much.
Thank you, sir. Thank you. Anyone? So okay, thank you very much for your patient hearing and support. We have another session with Anand Bamsar day after tomorrow. That is on Wednesday on 12th. That is on how to make good quality of brass casting production. Of producing, yeah. Hello. On 12th,
Hello,
yeah.
sir.
Your voice is breaking. Hello. Any questions, sir? Hello. You can go ahead, sir.
Hello, good evening.
Good evening, sir. Good
Hello,
evening.
am I audible?
Yes, yes, sir. Go ahead, sir.
Sir, actually, this is Tarun Mishra and I'm from Chandranchal. And
Yeah.
I have a question regarding. Hello.
Yes, yes. Go ahead.
Hello.
Go ahead, sir. Go ahead. I'm listening.
Hello, sir. Sir, actually, I have a question that we
Yeah.
are making DI fittings and pipes, okay? And
Okay.
in fittings, we are having socket items.
Okay.
And at that socket items, we are having groove.
Okay.
And maximum time I am facing. Yes, sir.
Yes, go ahead, sir. We have only 4 minutes
Yes,
back.
sir. Yes, sir. Yes, sir.
Yeah.
Yeah, maximum time I am facing a issue of sand penetration at the group portion.
Okay.
For a smaller diatom or a bigger diatom, almost cases we are finding a sand penetration.
So you have to check radius at that particular end, strength of the core at particular that area.
Yes, sir. We have already checked. Even though we have controlled over the sand parameters, even facing the problems. Because this case is not for a one or two pieces. Almost in every patterns at the socket portion we are getting this. For not generally for a smaller dia it's not that much, but for a bigger dia we are getting higher cases.
You have to also see the metal distribution also because it may not be a problem of the core making. It may be pressure of the metal that damages the core, or you can say take stand away from the core. So you have to see the metal distribution also, I feel. Because it is not for one or two cores, it is for 100 more than 70-80%. Then the metering also maybe one of the cause.
Okay.
So I think it is related to metal
Sir, yes, sir.
distribution more. Yeah. Okay, sir. Thank you. Thank you very
So
much. We
actually
are
I'm not getting your point, sir. The voice is not.
metal distribution. When you are pouring the metal, that metal distribution needs to be taken care. The flow of the metal.
Sir.
Ferroceric pressure you have to check, sir.
Okay, sir. Okay.
Ferroceric pressure you have to check, sir.
Okay, sir. Okay, sir.
Okay, sir. Thank you very much. So
Sandeep sir, very nice presentation today again.
thank you, sir. Thank you very much.
Congratulations. Thank you very much. All the best always.
Thank you, sir.
Thank you, sir. Thank you very much. We'll be back day after tomorrow with Anand Bam, sir, for manufacturing good quality of brass. Hmm?
Yeah,
Okay,
good,
sir.
good.
Thank you. Please join us on Wednesday. Thank you.
With Anand Bam.
Anand Bam, sir. Yes, he'll be there. Thank you.